3 days. It's long, man. Give yourselves a round of applause. You made it. Heck yeah. All right, I'm going to start the timer. I said I'd forget it, and I didn't. Nice. Hi, everybody. My name is Dan. I work at a company called Cerbos. This is KubeCon in London in 2025. That is my title slide. Thanks for joining me today. I get to work at Cerbos, on open source, and before this, I worked at lots of neat places like Ubisoft and Mozilla and Datadog, and I say this only as context to let you understand where I'm coming from for the remainder of this talk. I've gotten to dabble a lot in infrastructure, in development, and also in security. And a thing that I've learned along this path, I've learned a lot of things, but one of those things is that authorization, different from authentication, thank you very much, isn't just a security problem, although it's often relegated to that. It's actually a developer experience problem as well, and that's really what I want to talk about today. Let's start with what I call, and I'm not the only one who calls it this, is the authorization paradox, okay? Every single request in every single application, especially in today's modern whiz-bang cloud-native environment, right, needs to answer the question at every single encounter, is this user allowed to do this thing? Under what conditions, right? It's unavoidable. It's important for security, but authorization is actually treated as an afterthought in our architectures and our workflows, especially as developers, especially even as infrastructure people. And we've actually seen this pattern before. I'm a man of a certain age, and I remember when deploying was just a collection of bash scripts, or like setting and grepping and stuff like this, right? You probably remember when observability meant grepping through log files, as opposed to like a single pane, you got your Grafana and your Datadog and stuff right now. Our industry basically recognized these pain points and was like, we don't want to feel this pain anymore, what can we do? But authorization hasn't gone through this elegant developer transformation yet, right? It remains stuck in this sort of a weird, strange place. It's something that every developer has to implement, but few have good tools or patterns, really, for building it, right? So it creates friction rather than flow, and when something creates friction, we find ways around it, and sometimes not very good ways, right? This leads to this disconnect, and that's kind of what I want to talk about today. But let's step back and look at how we got here, right? So how has it evolved over the past decade? Remember networking? I remember networking. I remember plugging in stuff, right? We went from manually configured load balancers and firewall rules to declarative service meshes, CNI plugins, right? So we did that leap. Infrastructure concerns have now become developer concerns with clean primitives and clean abstractions. Storage followed a similar path, right? Moved from managing volumes and mount points to just declaring persistent volume claims, et cetera, right? CSI standards, deployments. You know, we transferred from error-prone shell scripts and stuff being done by hand. And I'm just going to super quick SCP this over to prod. We don't do that anymore. You don't do that anymore. Don't do that anymore, OK? And in this case, transformation made developers more productive whilst simultaneously improving security, improving reliability, right? That was the idea. So the pattern's clear. Like, you have good abstractions, and those good abstractions don't just hide the complexity. They really change how we work, and that's a good thing. So why has authorization remained kind of stuck? Well, it hasn't really followed the same evolution path, and part of the problem is that it's really often deeply coupled with application logic, which I'm going to address in a moment. It tends to like live inside business logic. It's not outside of it, like networking or storage, right? These are just things we need to do the business. Authorization is much more of a business level problem. So it makes it harder to extract, it makes it harder to standardize, it makes it hard to rationalize about, especially like our like weird developer brains. We don't oftentimes think about the business. And second, authorization requirements tend to be domain specific. Like financial services tend to have different controls than a SaaS product, or different controls than like Uber for dogs, right? There's no single model that works for everyone, and that's rough. Third, modern applications have like incredibly complex relationship needs and like objects and resource constraints and stuff like this. And you think about like, I don't know, Google Drive permissions or Slack permissions, right? It actually gets really, really tangled up really fast. And these aren't simple matrices of users and actions, right? You think, oh, like user A can access document B and has CRUD access on it. Like that doesn't exist anymore. It hasn't existed since the 90s, right? It's much more complex than that. There's no one-size-fits-all solution. It doesn't exist. A lot of people will try to tell you it exists. Those people are trying to sell you something. I'm trying to sell you something. That's beside the point. The reality is there is no one fits-all solution. It doesn't exist. So as a result, authorization, as I said, remains in this weird space between infrastructure and application and business. It's too complex to be standardized, too common to be solved afresh every time, right? In principle, at least. So this complexity has real costs. It can't just be ignored. It actually costs money, which is the issue, right? Developers constantly context switch between implementing features, enforcing permissions. You can look like controller code, business logic intertwined with authorization checks, and this tangled rat's nest of if-then-else statements. It's freaking disgusting. And it's super hard to maintain, especially if you've got like multiple mobile apps and like multiple this, multiple that, and deploying that, it sucks. These scattered implementations, they create security gaps. And it's hard to verify permissions are being enforced consistently. When they're spread throughout the code base, it slows velocity. No one wants a slow velocity. We got to go fast. We got to break things, except when the things break, and then what? Right? So if making changes to these permission models requires extensive testing, oftentimes like regression testing, because it's difficult to understand the full impact of these changes. And it creates this massive friction, especially for onboarding new team members, right? You're a new team member wading into this code base for the first time, and you're spending the first 3 months you're there just trying to figure out permission structures before you actually touch any features. That sucks, right? So it's not a security problem, it's not an infrastructure problem, it's a developer experience problem, and poor developer experience makes everybody feel bad. But what if we approach this differently, right, as like a workflow issue? What if authorization could be a creative tool instead of a constraint? Yeah? Developer experience is fundamentally about enabling flow, right? That flow state that we all love. That state where you're fully immersed in solving the problem, right? Super, super good. Authorization tends to break that flow, but it doesn't have to, okay? It can be declarative rather than imperative. That's really important. It can live in well-defined places instead of just scattershot across your application's code base. And with the right abstractions, it becomes intuitive. It becomes maintainable. That's the idea. And so the key insight, really, if you take nothing else away from this talk, and I'm going to give it to you right now, is that you got to focus on the workflow first, right? Focus on solving that. How developers interact with authorization during development is a big, big, big element. And we can create better security outcomes, better developer experiences, and that's what we're going to explore next. So when we architect, let's go ahead and say cloud-native applications, because look where we are, right? We typically give authentication the architectural attention that it deserves, right? Authentications, usernames, passwords, passphrases, identities. Oh yeah, we get that. We get putting in a password. We get putting in a security token. And that has a big architecture around it, right? But authorization often degrades into these scattered if-then-else statements, like I said earlier. And separating out business logic from database access and so on and so forth, it's important to make these clear boundaries, right? We separate business logic from database sources, database access rather. We create clear boundaries between business logic and permission logic. And this means authorization becomes a service, right? A service rather than just a bunch of lines of code. It could have its own APIs, its own contracts, its own testing strategy, its own development lifecycle, if we want it to. And these are all sorts of things we're comfortable with and familiar with as developers. These are things that allow us to have flow, right? Netflix actually famously took this approach on really, really early with their microservices ecosystem, and they found that centralizing authorization improved security and actually accelerated feature development. They have some really good white papers on this that you should go read when you have a moment, if you don't believe me. Their whole thing was focusing on core business logic without getting like bogged down in permission checks. It's a really good paper, so definitely go read it up. And so there's a really crucial mindset shift here, right? We frame authorization as a constraint. What can't users do? And this negative framing pushes authorization to the realm of security restrictions. And the better question really is, how do we enable the right access? That's the right question we should be asking, right? It's a positive framing. It turns permissions into a product feature. Whoa, whoa, right? When we make this shift, permissions become part of product discussions. They're not just relegated to security reviews and stuff you don't want to touch. They shape user experience through progressive disclosure of functionality based on context and constructs. Look at how Slack approaches workspace permissions, for example, right? They're not just security controls. They're collaborative features that enhance how teams work together. That's powerful. That's the difference between authorization as a constraint and authorization as a product capability, right? So To be clear about what we're trying to avoid, we're trying to avoid authorization that's added as an afterthought. We're trying to avoid context switching that kills that developer flow. Authorization logic that's tightly coupled with business logic becomes resistant to change, so we have to deal with that. Permission models need to evolve over time, they always do, and you end up refactoring core functionality. And I actually did a talk in Denver a couple weeks ago at an OWASP talk about how Facebook refactored a UI model and destroyed their permissions and made 15 million private posts public one time. That was a fun white paper too. Avoid that, right? The idea is that authorization shouldn't be a secondary thought. It should be treated as a first-class architectural concern. So let's talk about core design principles for workflow-first authorization. The first is domain-driven authorization. This means modeling permissions around business domains, not technical constructs, right? Now think about the business. I know as developers we don't want to, but we got it. Don't think in terms of CRUD operations on database tables. I know that feels familiar to you. We're done with that. We have moved past that now, okay? Think in the language of your product. Permission should speak the language of that product, not the code base necessarily, right? This creates a ubiquitous language between product and development and security teams, and everyone understands what editor means, for example, in a document system, but like update documents is a technical implementation detail, so which one of those two should you actually use, right? A document collaboration system might model permissions like editor, reviewer, and viewer rather than read, write, and delete, because that's what the product actually expects. These map directly how users think, and ultimately how the business and the product thinks about itself. And this is an alignment when you start to feel this way. It makes authorization more intuitive for you, the developer, for other people in your organization, and it makes the product more maintainable as it evolves, which is really, really nice. The next principle is using declarative policies rather than imperative checks, okay? Traditional code bases are filled with imperative permission checks. They're scattered all around. It's like, if user has permission, then allow this to happen, right? These checks, they're hard to audit. They're hard to test. They're hard to maintain, notably. Declarative policies, in turn, describe intent. What should be allowed, rather than how to check permissions, right? They become human-readable artifacts that can be version controlled. They can be reviewed. They can be tested independently of your application code. This is critical. Your policy should clearly express who can do what, based on business rules. It should live outside of your application code. It should be tested independently. It should be updated without changing your application. You don't want to actually have to re-roll your app and redeploy your app when permission models change. This is an anti-pattern. Remember that. Declarative approach scales with complexity. As your permission model grows more sophisticated, the policies remain readable, they remain maintainable, while imperative checks would create a tangled mess. Chopped up earlier. Third principle, use external decision points for authorization. Externalize your authorization, super important. Decouple authorization from application logic. I know I've been hinting at this, now I'm saying it out loud, right? Instead of embedding permission checks in your code, and your application asks an external service, can user do thing? This architectural pattern enables consistent enforcement across all of your software. That's what it does. That's the magic of it, right? That's what's so cool about it. All your microservices call the same authorization service. It's uniform. It's easy to reason about, okay? Your application grows, and authorization decisions then don't become a bottleneck that have to be updated. Okay? You can verify your permission model without spinning up your entire stack. That's pretty sweet, right? This doesn't mean authorization becomes a black box. It shouldn't be a black box, right? It should be treated just the same way the rest of your code and the rest of everything you work with works. It's not a black box. It's a service, okay? It's a service. It's probably got an API, and we're developers. We love APIs, right? Fourth principle is about making authorization context aware. Simple role-based access control, or RBAC, isn't enough for modern applications. It was enough when RBAC 96, right? That's when it was ratified. We've done a lot since 1996. So we need to consider attributes like time, like location, resource properties, relationship contexts, all these sorts of things. So context-aware authorization adapts to the situation. A healthcare system might allow access to patient records during business hours, but require additional approval after hours. Something as simple as that implemented as code, especially if you have a lot of exceptions, especially if you have a lot of doctors and a lot of sites and a lot of patients, right? A collaboration tool might check document status before allowing certain actions. So the idea is to have like fine-grained access control. So moving from RBAC to something like dynamic RBAC or even ABAC, attribute-based access control, which I can talk about for hours afterwards if you're interested. Let's talk about ABAC for a little bit, actually. You know what? Let's do it. Let's talk about some CNCF projects a little bit later on that do some ABAC. I think that's going to be good. So let's look at how these principles integrate throughout sort of this development lifecycle, right? So during requirements gathering, you need to look at your permission models. And those permission models should be defined alongside your features. Remember, we're not talking about tacking on permissions at the end anymore. These permissions and this authorization now becomes part of your product thinking. What access patterns does this feature need? How do permissions integrate with those existing models, right? And we're talking about API design. Authorization requirements should be explicitly documented in the API specs themselves, right? These aren't separate things. These are integrated in. Who can call the endpoint? What context is required for that call to be successful or not, right? During implementation, those clear interfaces for authorization checks make the integration consistent. And this helps with that developer workflow that we alluded to earlier. Developers should never have to invent new ways to check permissions. If you're inventing new ways to check permissions, something has gone wrong. You have gone off the rails. Okay? Testing. You need dedicated testing for your authorization, just like you have dedicated testing for your tests. We're all high-level, super good, test-driven developers here. We have 100% code coverage at all times, because that's how we roll here in this room. I believe it. I believe in you. Your policies and your authorization should not be any different. In operations where I spend a lot of time, monitoring observability for authorization decisions helps you to identify problems, right? So actually integrating policy checks, integrating authorization checks into your logs, into your audit trails, right? It's not just about did library fail or why not able to connect to this database? Like what permission checks are being made and how are they affecting the behavior of the system, right? Monitor that. It's not an afterthought, right? It's woven in at every stage. And the payoff here from this approach is substantial. It's substantial. Okay, we talked about how this costs money. This is how it stops costing you as much money, maybe even starts making you money. It's developer experience. Reduced context switching. The permission logic lives in well-defined spaces. It's easier to reason about. You have clear contracts between components. That makes integration simpler. Services know exactly how to request authorization decisions. So the actual code to develop those services is more straightforward. Self-documenting permission models. Heck, why not? Right? Team members can now grasp those permission models instead of having to spend weeks mired in the swamp, right? This leads to faster onboarding. This leads to faster feature development. These benefits are not theoretical, to be clear. Okay, I'm not making this up. They're practical improvements to everyday development work that we see in our customer face. Okay? They're achievable with these tools and these patterns. So let's talk a little bit about the authorization ecosystem. Let's look at some of the tools, right? Over the past few years, there's been an increasingly rich ecosystem of tools that's become available in the open source world. I'm only going to talk about open source stuff because I'm a hardcore open source nerd. Many have found homes actually in the CNCF, which is really super. So that is excellent. So we're going to talk about a couple of those. And this has helped drive standardization. It's helped to drive adoption. They take different approaches to authorization challenges. Remember I said at the outset that there's no such thing as a one-size-fits-all solution? So different approaches, different ways of thinking about it, right? Some prioritize scalability, some prioritize relationships, and so on and so forth. They all share a common goal of making authorization more manageable, okay? Let's see how this fits in. So first one I want to talk about is OPA, or Open Policy Agent, which you may have encountered. If you were on the sponsor floor over the past few days, a number of people here are talking about, hey, let's do OPA, right? It's a graduated CNCF project. It's seen wide adoption, some adoption. Not as much, I imagine, as we'd like across the industry. It's a general purpose policy engine. It's a general purpose policy engine, right? It can enforce policies for systems, Kubernetes, admission control, microservice API authorization, and at its core, something called Rego. Rego is a purpose-built policy language for expressing rules. It's a real language, right? So you're like programming your policies. It's quite powerful. It's super interesting. The architecture completely decouples policy from code. We talked about externalization, right? So it aligns with that principle that we talked about earlier. It is used at some pretty big companies. I alluded to Netflix earlier. Last I checked, Netflix is based on OPA, although I'm sure that my head of product will correct me on that after this talk if I am wrong. It's really good at what it does if it is what you need. But like a lot of general purpose tools, it's not particularly excellent at any one thing. And it can be difficult to struggle a little bit with Rego, which is probably why OPA hasn't seen the level of adoption maybe that the project in some ways deserves. So keep that in mind. So we have OpenFGA. OpenFGA is a CNCF sandbox project, which is really cool. It's focused on relationship-based authorizations at fairly large scales. OpenFGA is based on Google's Zanzibar paper, super interesting computer science stuff if you're into that, which describes the system that powers their permissions, like for Google Drive and like YouTube and all of their services, right? The sort of planet-scale relationship-based architecture, right? Auth0 created an open source implementation. That's part of the CNCF. It's specifically optimized for like doing relatively high performance at scale. But again, it's all about modeling complex, arbitrary relationships between objects. And if that sounds like a little bit abstract, it's because it is. You know, it's, for example, not very good at RBAC, right? It's only marginally good at AVAC. So if your problem is your Google, this is probably what you want. If your problem is we're anything other than Google, it might not be what you need. But it's really, really interesting, and I highly recommend taking a look at it. I do want to mention, and we're going to step away from the CNCF here for a moment and talk about some other open standards, which are important, is the OpenID Foundation. The OpenID Foundation has established the Authz working group to standardize authorization APIs and interfaces effectively, right? So taking this whole smorgasbord of possibilities that exist out there, I'm going like, hey, like, can we get together as an industry and come to some conclusions about how we want to work together? And this group's building on the success of OAuth 2, on the success of OpenID Connect, notably, if you've ever encountered these things before, which has solved similar standardization challenges for authentication. The focus is on interoperability between authorization systems, creating sort of common interfaces that different implementations can support. This works around creating an open dialogue, right? For authorization systems across platforms, across vendors, and it's super important work. It's slow going because how do you get enemies to talk to each other? It takes a little while, right? Enemies, competitors, right? To talk to each other. That's how it is. It's less about specific implementations, to be clear, although they do have reference models, and more about ensuring that different systems can work together coherently. And Authz, which you see up here, Authz represents an important sort of effort for the long-term evolution of the authorization ecosystem. So if this is a world you're getting into, this is a working group that you need to get familiar with, right? Cerbos takes a different approach. Cerbos is involved in that OpenID working group, is involved in Authz, uses human-readable YAML policies that product teams can understand and review. These policies sort of clearly express who can do what to which resources under what conditions. And the thing I want to point out here is that I think it actually has pretty good developer experience, which is maybe a little different from the other model or the other tools we mentioned earlier. You know, Playground for testing policies that has an inbuilt testing framework, I think, which is pretty good. Simulating requests, examining traces. It feels more like a developer tool than some of the other ones, which feel more like a bit of an obscure endpoint or service. If your priority is making authorization accessible, I think Cerbos is probably worth taking a look. So, how do you choose among these options? I just gave you a bunch, right? There's no one-size-fits-all, as I said earlier. Your choice should really depend on your architecture. It should depend on your need, okay? Consider OPA if you need broad policy enforcement beyond just sort of authorization. So, we might choose OPA, for example, if you need configuration validation or Kubernetes admission control or something like that, right? They're a broad service, okay? You can look at OpenFGA if you have complex relationship-based permissions at planetary scales, particularly for those user-to-user sharing scenarios. You should look towards Cerbos if you like those developer workflow integrations and a certain level of simplicity belying that complexity is what you're interested in. Many teams actually end up using multiple tools. This isn't necessarily weird. You probably have multiple tools to do more or less the same thing in your environment. Pick the one that makes sense, and if two makes sense, pick two. It's okay, right? The important thing, again, is to settle on those principles we talked about earlier. So let's see how to implement these tools a little bit more effectively in the 5 minutes we've got left. Good luck, Daniel. Now that we understand the principles and the logic, let's talk about some overviews. These are battle-tested approaches, architectural patterns, development patterns, testing patterns. Each pattern addresses a different aspect of the authorization challenge. So first we have an architectural pattern, so policy as a service. This pattern encapsulates all of the authorization logic in a dedicated service that your applications can call to make authorization requests. Your applications can make explicit authorization requests, can user X perform action Y on resource Z or Z. This policy service returns a simple yes or no, right? You just get that yes or no back, done, right? It enables consistent enforcement across services, and the same policies apply everywhere. It simplifies policy updates. When the rules change, you update the policy service without touching the application, right? You want to have like maybe a REST API or something you can make gRPC requests against. This is what we're looking at here. When we're thinking about policy as a service, this is what we're aiming at, right? A pattern works really, really well, for example, in microservice architectures or anywhere where centralized governance is important, and policy changes end up being frequent, okay? We also sidecar, because we're at CNCF, everybody likes Kubernetes, right? This takes a different approach. So instead of calling like a centralized service that exists somewhere in your whatever, each application instance has its own authorization sort of engine that's applied along with it, or it's deployed along with it, right? Typically as like a container sidecar, or maybe as part of a daemon set. I mean, you do you, right? This gives you very low latency for those authorization checks. Since there's no network hop or minimal network hop, depending on how you're doing things, sidecar runs in the same pod. It makes those local calls really fast. And especially if you're putting authorization in the critical path, and you should be putting in your critical path, this is a really good model for dealing with network latency, for dealing with environments where maybe you don't necessarily have the time or the luxury to wait for a round trip, right? Obviously, it shines in Kubernetes environments. You can implement it with Envoy if you felt like it. It works super nice, right? The idea is to eliminate those network dependencies instead of having a central service, whilst still getting the advantages of having an API or an endpoint that you can just call programmatically. You can also look at multi-layer authorization, right? So patterns that recognize different types of authorization belonging in different layers of your stack. Your API gateway or your ingress layer was maybe we're going to have some coarse-grained checks where you might be even just validating the authentication to a certain degree, right? You also do API check verification. Basic role checks could occur at this layer, for example. And then you can move to the service layer, right? So where you can enforce that business logic authorization. And you can use this to perform user checks, right? Can a user perform this action at their current level of access and of these current conditions, time of day, et cetera, et cetera. And then you get into the data layer. And the data layer, you might be implementing like row-level checks, authorization checks, object-level authorization checks, right? Security for that really fine-grained access control at a fundamental primitive level. Each layer handles what it's best at. And this creates, among other things, and I know we're going to talk about security, but I'm going to talk about security for a moment because I really like OPSEC. It actually helps creating this defense in depth model, if you've ever read about that or heard about that. So this is, again, what you want to kind of be aiming at, but I'm getting off track. So a practical implementation of this would sort of integrate all of these. And I realize I'm going super fast, but don't have a lot of time. So moving to development patterns, policy-driven design flips the traditional implementation sequence, right? Instead of writing code first and adding authorization later, you start with authorization requirements. This is the Authz equivalent of test-driven development, right? So write your tests, test them, and if your policies are spitting back to you what you expect them to, then write the code that uses them, right? This works really, really well because it means you know that your authorization is going to do what you expect, and you can bundle that into your feature set. You can even use these policies to drive API design. If your policy says managers can approve expenses, for example, then your API needs endpoints that expose that capability appropriately, right? You can use this to drive your API design in an intelligent way. Like, shout out Cerbos, we're really good at this. OK, you also have request context enrichment. This pattern addresses an important but really practical challenge, which is that authorization decisions tend to need rich context. Right? You need a lot of context to make a good authorization decision. These include user attributes, resource metadata, environmental factors, relationship information. Right? This is where RBAC starts to fall apart. You need to be able to bundle all of that together and go, hey, we have got these complex, distributed, emergent systems with a ton of rich contextual information. Use that contextual information to design good authorization policies. Implement that in a request middleware, or integrate that in an interceptor somewhere, right? This rich context makes your authorization rules a lot more powerful, a lot more flexible. I'm running out of time, so very, very quickly. I have so much I want to say. I have so much I want to share with you because it's such a huge thing to mine, and I love it. OK. Policy testing. You have to test everything. You have to test your policies. If your authorization solution doesn't have tests built into it, yeet, you need something better than that. All right? You got to have the testing. Super important. Test fixtures. Oh, my God. Practical workflow integrations, IDE plugins. It's all so good. OK? Whew. These transformations aren't just theoretical. OK? They're happening in organizations around the world today. I'm not talking out of my butt here about stuff that doesn't exist. This is how we move from friction to flow in the authorization process. This is how authorization becomes part of your creative workflow rather than an obstacle. Developers spend more time building features this way, right? Less time wrestling with permissions. That sounds good. We shift from security as an add-on to security by design, defense in depth. It becomes integrated into the architecture right from the beginning. It's inherent in how you build. That's the goal. We create a situation where we can empower developers to make better security decisions. We can allow developers to make better product decisions. That's huge. Teams understand the why in a way that they wouldn't have before. We create friction. We eliminate friction to create flow. We get that security by design. We get that empowering of the developers. So where do you go from here? Where you go from here is Discord, and Slack, and Docs, because this is the start of your journey. Thanks. I appreciate y'all hanging out with me. I'm a little over time. I will hang out over here if you have any questions. Otherwise, safe travels. Be well, everyone.